Mo to siya, no? On this one, we have a dynamic equilibrium by applying the concept of the Allenberg's principle. Okay, next, moving on. So from the structural, from the simple structure, the single degree of freedom structure na to, from the idealized structure, we try to describe its motion, and then tackled a little bit about the equation of motion. Now we try to apply the equation of motion of a one-story building subjected to a dynamic force. So on this side now we have our idealized structure. Now, this idealized structure with its roof no having the mass m has an applied dynamic force. Can you see? P vector, P of T vector. So this is an applied dynamic force of T. Now, since the column has a lateral stiffness, it will try to resist this applied dynamic force. So na resistance si column dira. We call that the elastic restoring force, symbolized by F of S. But as a function of time and at the same time it is vector. And then we know that the elastic restoring force caused by the stiffness of the column is not enough. The behavior of this structure will become unrealistic. That's why we apply the energy absorbing element. We have here the damping force. So we have a damping force here, symbolized by f of d as a function of time, f sub d is a function of time, and then at the same time this is a vector. So this is opposite to the direction of the applied dynamic force. Pasabot, it will absorb energy until the structure will eventually come to rest. So to have a dynamic equilibrium, what we have here is, since we have a mass of the structure, so there should be a inertia force f sub I of t, and then that is a vector quantity. So for our FBD, so we have an FBD here. We have an applied dynamic force on that direction, and then we have our resisting force here, the elastic restoring force caused by the column. So that is 1/2 f of st as a vector, that is a vector quantity. And then another half here, f of s of t, fs of t. And then we also have the damping force. So we have elastic restoring force and the damping force, and then the inertial force. And then we'll have our dynamic equilibrium. So at any instantaneous time, the mass m is under the action of four types of dynamic forces. So after we discuss later four types of dynamic forces. So as you can see, no, the structure is moving. It's a lateral displacement. So kalimot no atong symbol sa lateral displacement is U of T. So muna siya here. This has a lateral displacement or deformation. Now, if we try to differentiate the lateral displacement with respect to time, we will have our lateral velocity, or also call that our response velocity. Humaning response structure sa applied dynamic force. And then if we differentiate again for the second time the position or the lateral displacement, we will have our response acceleration. So muna siya ang response ni structure. And this one here is just the unit vector, since this is a vector quantity. So muna siya. We have the displacement, the velocity, function of time or u dot t, Then we have here the acceleration as a function of time. So this is a vector quantity. U double dot T. So na-mention man nga there are four forces that act on our structure. So we have again the external dynamic force that symbolized by P of T. Next one we have the inertia force. This one katong Fi of T, that is mass times acceleration, or negative m double dot T, or negative m double prime negative m negative mass times the uh, second derivative of the displacement as a function of time. Next, we have the elastic force. So, mali siya katong restoring force. The key is the lateral of the two columns combined. So, negative sign man, it means that the forces is always in the opposite direction to the structural deformation. So we have the deformation, di ba? Times the lateral stiffness. So pasabot, sa negative is that it is always opposite sa deformation. Pasabot, the structure is to be brought back to its neutral position. Pareha sa kuan, di ba, sa katong elastic rebound theory nato, I already said or discussed that uh, as the plate or the fault, there is a movement of the fault, no, dahil energy nga gaka-produce. There is an elastic stress. Until such time nga dili na ma-carry adtong two slabs of rock or sa fault, and then it will release that energy. We call that the rebound, and then that energy will travel throughout the world as a form of P waves or the S waves. So here also we call that, no, diba, elastic rebound. There's an elastic stress, and then there is restoring force. So same here also, there's a restoring force sa tuang structure. Next one, the fourth force, we have the damping force. So mo ni siyang ga-absorb sa energy. So the formula here, that is the negative C times the first derivative of the position with respect to time, or can be written as negative C U double dot of T. No. U dot of T only. U dot of T. Or negative C U prime of T. So, aron di mo malibog, ato na lang isa-isahon. So, our C here, this is our damping coefficient. So, ganong negative sign. So, if si elastic restoring force na to, negative, si elastic restoring force na to, di ba, that is negative K U of T. So, negative na to oppose the direction of the displacement. Si ano po, si damping pod coefficient, negative siya, si damping force to what? This is always opposite on the direction of our velocity. So it means it will dissipate energy. So ganun man sa mga relationship ni energy of ni sa structure. So kabalo man tadi ba, we have our kinetic energy that is equal to 1 half mv squared, the square of the velocity. So this one, the damping force tries to resist that or dissipate the energy caused by the movement of the structure, or the caused by the applied external dynamic force on our infrastructure. So kung i-apply na to si D'Alembert's principle, di ba, we have the sum of all forces must be zero. So if kung imong mamaligdan, no, we have the dynamic force 1, 2, and 3, and then here we have the applied external dynamic force. So the sum of these four, what do you call this? Four dynamic forces should be equal to a null vector. So ato nang gina-consider din diri that our force, vector force 1 is this is the inertia force, vector inertia force. Here, this is the vector dynamic force, damping force. And then lastly, we have the elastic restoring force. So all of these are as a function of time is equal to our external dynamic force or applied force. So, the vector can be converted to a scalar function, of course. Mo man itong ginabuhat before, di ba, in our lower years. We try to convert vector quantities into scalar forms. So kung sa physics, sa dynamics ninyo, if you have force, no, if you, let's say you have a rectangular components or you have a this one, and then there is an applied force, and you try, so we have a vector force F here. So you try to break that down into components. So we try to get the force uh, on the x component, on the y component, and then on the z component. So here, Japon, this vector quantities can be converted into function. So muna siya. This is just the scalar function of the equation of motion. So kung ato na siyang isulat sa other form, that is just what? That is just mass times the acceleration plus the damping coefficient times the velocity as a function of time plus k or the lateral stiffness times the lateral deformation u of t is equal to the external dynamic force as a function of time or mu double dot t of t plus c u dot of t plus k of t is equal to p of t in our scalar form. So other times po no na po other sources nga x man ilang ginagamit for displacement. So we have here no k x of t is equal to p of t. And then so the velocity will be on this part here we have the c, the damping coefficient times x dot of t, then mass times the x double dot of t. Take that the mass is constant, the damping coefficient is constant, and the lateral stiffness is constant. So this is the our equation of motion. You take this down. You take note of this. And if you notice, this is a second order linear ordinary differential equation. So this is an ordinary differential equation because there is no partial differentiation here. Second order, because of this one, it is there is a differentiation up to the second order, and then at the same time, this is a linear equation, differential equation. So, muna siya, na-simplify na din natin sa equation of motion into this form.